Hello and good day, Algebra. Today we're going to talk about equations. And this was on your entrance exam, solving an equation. Today we get into two-step equations. I understand that Mrs. Feynman taught you the railroad tracks. That's what this is, okay? I'm not as creative as she is, so I don't have a cool metaphor, railroad tracks diagram thing. We call it here opposite operations, because if you think about mathematically what you're doing with the railroad tracks, you're undoing the equation, right? You're whatever operations are present in the equation, you're doing the opposite to solve it. For example, negative 8n plus 11 equals negative 21. I'll draw my tracks in there. Choo-choo. What would you do first here? Raise your hand and tell me what you would do first here to isolate n, get n by itself. Max.
I would do 11 minus 11.
And why would you subtract 11?
Because it's the opposite of adding 11.
Right, and what does that do? Well, what it does is that subtracting 11 from both sides, and again, notice it's the opposite operation of adding 11, right? What it does is it cancels that 11 out on the left side. Okay? Why that's important is because if we want to get n by itself, we have to get rid of everything else. Okay? And then why do we subtract 11 from the right side also? Why is that an important step that we can't miss? Catherine? Yeah, why is that? The golden rule for solving an equation, right? What you do unto one side, thou must do unto the other. Alex? Oh, Kylie? So the equation stays equal, so it stays balanced, right? Have you worked in science class before with these balanced scale deals, right? Well, if you haven't, they look exactly like that does. Okay, but basically, an equation is like this balanced scale. Is that when two things are equal, they are balanced, right? And if we subtract 11 from only one side and not the other side, what's going to happen to our balance? Kerplunk. Okay, it's going to tip. So we need to make sure that we are doing the same thing to both sides. And then what would you do as a final step here, Damien?
Oh, I just have a question.
Yeah.
So it says the opposite of permgas. Can we call it sad?
Sadmrip? Sure. Yep. What would our final step be here, Bryn? Divide by negative 8. Don't forget that sign. Okay. On the right side, negative 32 divided by negative 8 equals positive 4. And how does dividing negative 8n by negative 8 cancel out the negative 8s? How do we get n by itself here? Mathematically, what's going on, Anthony?
Well, since you divide 8n by 8, then if you put the 1 in front of the n, but that 1 is invisible.
Exactly. This doesn't equal 0, like positive 11 minus 11 equals 0, so it's gone. But negative 8 divided by negative 8 equals a positive 1. Anything divided by itself is 1. And so as Anthony said, you can put the 1 there. You don't have to, because 1n equals 4. That's the same thing as just saying n equals 4. There's only one of them there. Okay, there's no coefficient written. It's understood to be a 1. Finally, math is great because you can check your answer, and it's like I'm encouraging you to cheat. If you're taking like a science test and you're asked for the definition of a zygote, and it's not like, I don't know, I just picked a sciencey word. You can't like look it up, right? You can't check your answer. You can do it in math, and I want you to do it. You can make sure whether or not you're correct, and I encourage it. How can you check this answer to ensure you're correct, Christopher? Exactly. If n equals 4, then negative 8 times 4 plus 11 should equal negative 21. Okay? If it does, you know that you've solved for n correctly. If it doesn't, then you got to go back, look for sign mistakes, look for silly mental math mistakes, or whatever. Okay? This opposite operation method is review. You've done them before, but it's a good chance, in addition to the entrance exam, just make sure we're all coming in at the same spot. That's why it's a PO. It's important. All right? Questions on this? Okay, let's look at one like the third one there. N divided by 5 minus 6.5 equals negative 4.5. Okay, it's all fun and games until you start adding fractions and decimals. What would we do first here? What would we do first? Alex? Add 6.5. The opposite of subtracting 6.5 is adding 6.5. And that would give us n over 5 equals negative 4.5 plus 6.5? Just 2. Okay, just 2. Remember that negative 4.5 plus 6.5, you can rewrite that to be positive 6.5 minus 4.5, right? Because as long as you keep the signs the same, you can reorder addition and subtraction. And if you think about it in that way, most you can probably easily come up with 2 as an answer. Okay? What do we do now? Catherine? Yes. Why would we multiply by 5, Catherine? Right. Remember that a fraction is the operation of division. So n divided by 5, to undo that, we're going to multiply by 5, and we get n to equal 10. I like where we're at here. This is good stuff. You folks are coming in on fire. Okay. Do those other 2 that we haven't done on your own briefly. I'm going to pause the video to give you time, and we'll come back and we'll discuss. But just do numbers 2 and 4 in the interim. Okay, here we go. By now you should have completed numbers 2 and 4. So what did you get for 3n plus 17 equals 77? What did you get as a solution? Joey? N equals what? Sorry? 20. Do we agree?
Yeah.
We can plug that in and check it. 3 times 20 is 60, plus 17 is 77. Mathematically, what we would do is we would subtract 17 from both sides. 3n equals 60. We would divide both sides by 3, and there we get the n equals 20. Okay. What'd you get for the fourth one, Vince? N equals what? Negative 66. Plug that in. Negative 66 divided by negative 6 is positive 11. 11 minus 4 is 7. It's 66. Check those signs. Check that answer. 66 divided by negative 6 is a negative 11, and negative 11 minus 4 is negative 15. Mathematically, we would add 4 to both sides. Multiply, folks, multiply by negative 6. And that gives us n to equal positive 66. Okay? But this objective does not simply say I can solve a 2-step equation. No, it says I can write and solve equations in real context. And now that we've got the solving part down, we're going to look at the writing part. So down the page we go. And let's look at some word problems, because the difficulty, we've talked about this before, the difficulty with a word problem is that the equation isn't just there for you, right? You have to figure out what operations are going on, what's my variable, where's everything go, okay? And that's actually how things work in the real world, you know? When you're trying to do something mathematical in life, the equation doesn't just appear in front of you yet. Maybe in 2030, by then we'll have the technology where it just appears in. But no, you got to write it yourself. So let's look at the different pieces of an equation. Variable, coefficient, constant. Maybe you've heard these terms before. I know variable you have. Maybe you haven't. But who can tell me what the role of any of the 3 are that you've heard of that you know? Yeah. Jack.
Which one?
Anyone you want.
Variable.
What can you tell me about a variable?
It's a letter that substitutes for a number.
Okay. So in your equation, it's usually a letter. It can be a symbol also. It's just something that represents an unknown. But we usually use a letter. It can change, right? You can plug different values in for a variable to test different things. But generally, it's what we're solving for. Right? If you're doing an experiment, a variable is something that you want to plug different things into, test different values, see what works, see what doesn't, see what works best. In our context, for math, it's the answer to the question, usually, right? It's what we're solving for, what we want to find out. Okay? How about coefficient or constant? Christopher. Number attached to the variable, what does it do? What is it like if we have the term, 4n, 4 is the coefficient, but what does that 4 represent? Okay, we are multiplying 4 times n. Good. What else? Crinkle?
It represents the number of n.
Yes. Okay. The coefficient tells us how many of the variable we have. Okay? How many of the variable we have. In the term 4n, we've got 4 n's. 4 times n. Okay? As Christopher said, it's the number before a variable. As William said, it means that we're multiplying. 4 times n. Yeah. Jack.
The constant is it's like the number that you're adding or subtracting from the variable.
Okay. Number that is added or subtracted from the variable term. Number that is added or subtracted from the variable term. Okay? In the context of setting up an equation, think about it as what you start with. Right? In the context of setting up an equation, think of the constant as what you start with. Because the constant is not affected by the variable. Okay? Let's look at the first example here. It says, you sign up to help a charity with preserving the rainforest. It's noble. They ask for $20 up front, and then you will give $2 per month after that. Write the equation, and how much money will you have given after 6 months, 8 months, and 2 years? Okay? So let's kind of run through what is our variable, what is our coefficient, what is our constant? What's our variable? What changes? What are we asked to solve for here, Ellen? How long? Okay. In the context of this, we've got months, years. Let's have our variable be m, and that's going to represent months because we can convert years to months pretty easily. Okay. The variable is what we're testing is, how much money will we give after we've been a part of this charity for so much time. Okay? What's our coefficient? What's our coefficient? Alex? Why 2? Yeah. As our length of time increases, so will the amount of money that we give at a rate of $2 per month. This word right here is important. The word per, each, or every will very often connect your coefficient with your variable. If you're ever looking for coefficient and variable, look for the words per, each, or every. Okay? And then what's our constant here? Claire?
I have a question.
Yes.
Isn't the variable usually money because you're trying to figure out how much money you use?
Let me clarify that. So the total money given is ultimately what we're finding here with this equation. But the variable, what can change, we're testing it after 6 months, 8 months, and 2 years, right? So we're using that to calculate how much money's being given in total, right? But what can change here is the time frame. So this is almost a scientific experiment in that we're testing multiple things here. Okay? Crinkle.
Can I say what the
Constant? Please.
It's $20.
$20. Okay? It's what you start with, right? You give $20 up front, and that $20 is given whether you're a member for a month or 10 years or 43 million days, right?
2 days.
Okay, or 2 days, yeah, right? That 20 is gone, it's spent, it's upfront, it doesn't change. So put this all together here. What is this as an expression, right? This is going to equal the total money given, right? But what does all this come together to look like here, Ellen? 20 plus 2m works, right? $20 given right away plus $2 per month equals the total money given. What's another way that we could write this? Jack?
2 plus 20.
Right, you can switch these around. 2m plus 20, and it would equal the same thing. Okay? And so then when I ask you, how much money will you have given after 6 months, what do we do to solve this? Or to answer that? Red. Plug in 6, right? 4m. So that would become 2 times 6 plus 20, which equals 32. Okay? Then it says, how about after 8 months? Well, same thing, except now it's 2 times 8 plus 20, which equals what? 36. 16 plus 20. Then it says 2 years. What do we got to do here?
Well, there's 12 months in a year, so you add 12 and 12.
We have to plug in 24 to represent 2 years because our variable is in terms of months, right? So we have to convert 2 years to months. That's why I plugged in 24. 2 times 24 is 48 plus 20 is 68. Okay? Next one. Mr. Schultz has 3,039,001 hairs on his head, and each day he loses 60 of them. Write the equation. How many hairs will he have left after 120 days, 1,580 days, 50,650 days? Okay? Let's start. We have our variable, we have our coefficient, and we have our constant. So I'll kind of abbreviate those CF and CN. What's our variable here? What's changing? What are we plugging in? Anthony?
H.
Not hair's kind of like our final answer, you know. Hair represents what's left after we solve this expression. Days. Okay? Days. We'll do D for days. Because that's what changes, right? That's what we're testing. What's my coefficient? Aiden?
60.
Not 60. You're close, but think about the situation. This is what makes word problems difficult. Think about how does my right, who said I lose 60? Negative 60, right? Because I'm losing 60 hairs every day. So every day that passes, right, I'm losing 60 more. This is what makes word problems challenging, right? Pulling that out of there. But it is a negative 60 because I'm losing 60. And what's the constant? What are we starting with? 3,039,001. Okay? So, all this together equals the hair I have left, right? But put this together as an expression. How do we combine our variable, our coefficient, and our constant together? Damien.
I just have a question.
Yep.
So, like on the last one, technically, once you get it, they were asking for $20, so wouldn't that be subtracted if you were losing $20?
The question wasn't how much money have I lost, it's how much money have I given. Yep. Yep. Beckman.
You wrote 3,059,000.
That's supposed to be a 3. I didn't make my top curve. Arlene.
I think I know.
Yes, put it all together.
Okay, so 120 times 60.
Let's just don't plug in values for the variable yet. Let's just get the general equation. So use D for day. Don't plug any numbers in yet. Kind of like we started with here. We didn't plug anything in yet, right?
So D times 60, but leave the negative outside.
Okay, and we can write that as negative 60D, right? Because that says negative 60 times D. It says for every day, I'm losing 60. So negative 60D, and then Ellen? Okay, so I could put 3,039,001 minus 60D, right? Because I'm starting with that and subtracting 60 per day. But remember, we can write things in multiple orders. If I put my negative 60D first, Bryn, plus 3,039,001. They both give you the same thing. Okay? One starts with what I start with and subtracting 60 per day. The other gives you the total number of hairs lost first and then adds what I originally have. Both will get you the same result. So, after 120 days, we'll use the second one here just because it's right below it. How many hairs left after 120 days? Catherine? 31,000 what? 801. Do I have a second on that? Yeah? Okay. After 1,580 days, same thing, only instead of 120, I'm plugging in 1,580. How many hairs do I got left? Catherine? Okay. I heard someone say that this is so confusing. How can I help? Where are you getting caught? Well, we don't need to call anybody out. Oh, okay. Oh, okay. Damien.
I'm confused on like the coefficient and the constant.
The difference between them?
Yeah.
So the constant is always kind of what you have to start with, right? It says that I've got 3,039,001 hairs currently. That's what I currently have. That's what I'm starting with, right? And then remember those 3 words that I said connects the coefficient with the variable? Per, like we saw in the last one, right? $2 per month. Here was our coefficient variable there. What were the other 2? Per, each, and every, right? Here we say we see each, right? Each day he loses 60 of them. Okay, so it connects that negative 60 because I'm losing them, right? Negative 60 with our variable d. Okay? It takes practice, but you can also look at, as far, well, variables kind of easy to pick out. Okay? But look for those words, per, each, every. And then finally, the last calculation, 3,039,001 minus 60 times 50,650. How many hairs will I have left after 50,650 days? Jack? 1.
Oh no.
I hope it's really long so I can like just wrap it around and fold it over and make it look like I've got more. But 1 after that many days. Yeah, a comb over and over and over and over and over and over and over again. That's what I'm hoping for. Okay. I don't know. I'll let you know in 50,000 days. Okay. Any questions on what you see up here? Folks, Jack, no, I don't know.
You can.
Shh, we're not going down the rabbit hole. Stop. Questions on what you see up here? Alex? Yes. Calculators are allowed. Okay. Your homework then, on the second page, you've got 8 equations to solve, all just straight up opposite operations, railroad tracks, whatever you want to call it. Okay. Those 4 that we did on the front side. Practice that here. Then you've got 2 of them where you need to write an equation to model each situation, then answer the questions. I want you to, oh yeah, green is in timeout still. I want you to identify your variable, your coefficient, and your constant for each of them. Okay? I will give you a little bit of a hint for this first one. Let's read it together. It says you are just starting to collect baseball cards and already have 30 you got from your parents. What's that 30 represent? You already have 30 you got from your parents. Constants, what you're starting with, okay? You go to a trading store with 3 of your friends with the agreement that however many cards the group gets, you will divide them evenly among the 4 of you. Now, on the front side, or the first page, we dealt with multiplication in each of the ones that we set up. What operation are you going to be including here? Division, okay? Which, when you think about a coefficient with division, I'll remind you, when you have something, and I'm just making this up, so don't write this down, it doesn't apply to this specific question, but if you have something like n divided by 10, how can you write that as multiplication so you would have a coefficient? Because right now, there's really not a coefficient to n, right? But how can you write n divided by 10, just as an example, as multiplication? Dividing something by 10 is the same as nope. Alex? Not multiplying by 10. Bryn? No. Multiplying by 1/10. Okay? Dividing something by 10 is the same as multiplying it by 1/10. Just like, maybe I should have done this example instead because you're more familiar with it. Dividing something by 2 is the same as multiplying it by 1/2, taking half of it, right? 10 divided by 2, half of 10, it's the same thing. So when we talk about the coefficient, even though this is dealing with division here, write it as a multiplication term, and now you've got that coefficient of 1/10. Okay? Special guest, Mr. Olson. Okay? Questions?
Pay attention.
Yeah. Oh, yeah. Questions on what you are to do for homework? Aiden.
Multiplication thing, do you just put a 1 over the number that's being divided by?
Yes.
Okay.
Yep. October 1st. Not applicable now, though. So save that for when we're not recording. Okay? Questions, comments, concerns, complaints, compliments, congratulations, or criticisms?
Thank you.
For?
For getting a college degree.
For making, for actually being, for having one hair.
Aiden.
Congratulations on losing your hair.
I'm dead.
That's how you math.